Last time what we did, we made up a solution, and what I want to do is move on from there. I want to look at these concentration things, and to do that, some of it we're going to use titrations, which is one of the things that sort of worries a lot of students. So let's have a look at what we did last time, but I'll do it a completely different way. So let's go over and have a look at an experiment. Right, so let's see if we can make up a solution. Now we're going to have a look at titrations. I'll move this out the way for the time being, and what we're going to do is we're going to try and make up a solution here of copper sulfate, and I haven't got all the equipment here that I want, and so we're going to manage as best we can, because what I'm going to do is I need to make up some copper sulfate solution because it looks like I'm running out. So what am I going to try and do? Well, I've got my balance and I've got some copper sulfate. To go with this, I need some distilled water, and what I also need is something to make it up in. And what I need to do is make up about 250 mils, so about the amount of stuff that's in here. Right, on a spatula. I could get out a nice stirring rod to try and do this with as well, and we're ready to go. What I need is to do some calculations. To do some calculations, we need to know something about what I'm working on with, and this is copper 2 sulfate pentahydrate. So let's have the formula for this. So there we are, you can read what I've got out. There we are. Okay, so 98%. It's not nice to the environment. If you get it on your skin, then plenty of soap and water, because this stuff isn't very nice. Right, let's take it over and we'll do some work with this. So some calculations first. We need copper sulfate, so this is CuSO4.5H2O. So let's do some work with this. And let's get our periodic table out. So copper, we see, is 63.5. We've got sulfur. Sulfur is 32. And then oxygen is 16. And we've got 4 of those. 4 16s, 64. Plus I've got water, and I've got 5 of those, which are going to give me 5 lots of 18. Let's go over to the calculator and see if we can work out what we want to do here and do our calculation. So our calculation is going to be 63.5 plus the sulfur, which is 32, plus the oxygen, which I've worked out is 64, plus we've got water, which is 18, and I've got 5 of those, so I'll put those in brackets and we work out what this is, and it comes out at 249.5. I want to make up a 1 molar solution. So to make up a 1 molar solution, I would use 249.5 grams made up to 1000 centimetre cubed. But I don't have a 1 litre. I'm going to put this into a bottle, and I've only got about 250 to play around with. So we want a quarter of the amount of liquid, so we want a quarter of the amount of substance. So here is my calculation, and we can simply here take this and divide it by 4, and we can say that I need 62 grams to make it up. So 62.375. Now that's quite a strong solution. We'll have a look, and let's go and see if we can make it up. Now, there's various ways that we can do this, but unfortunately I haven't got my volumetric flask that I would like to use that we used last time. This one contains lime water, and I haven't got that available to me, and I want, that's a 500, and I want to make up 250. So we're going to do it in a slightly worse way. It's still going to be reasonably accurate, however. And what I'm going to use for this is a measuring cylinder. Nothing like as good, but we can use it anyway. Right. Amazing how simple items get in my way. I didn't want everything to fall on me. Alright, okay. I have everything that I need. I've got my container, and I'm going to place that on here, and we're just going to switch on the balance, and it's set here. I want to put in 62.375 grams, so let's get out a spatula and start putting it in. So it appears I've got quite a long way to go with this. We're at 31, go faster. 42. You're looking, I'm not, I'm just putting the stuff in, trying to make sure I don't spill any. 51, we're getting there, so we've got to get to 62.375. So 61.16. $62.37. I know I need 62.375, but I can't measure that any more accurately on this balance because it only goes to two significant figures here. Right, so let's now switch this off. We don't need the balance anymore. And what I need to do is I want to put some water, and I want to make it up to 250. And here, this isn't very accurate. The measuring cylinder will be more accurate, but what I'm just going to do is pour some water in here. And I put in about 150 mils here, and what I'm going to do is I'm going to give this a stir, and I'm going to use for this a stirring rod. We've got quite a nice blue colour coming of copper sulphate. I'll pour a little bit more water in there. We're up to about 200 now. Now if I want this to dissolve, then swirling the bottle is usually quite a good way of trying to get everything to dissolve nicely. And we are getting somewhere with this now. What I want to try and do is ensure that all of this has dissolved in here. And we'll give it another little mix. I can still feel some solid crystals at the bottom. If I look, I can see I've got a few nearly dissolved, just got a few left that are going on. Now this isn't going to be an exact concentration. For that I'd need to use a volumetric flask, but for what I'm actually doing I only need really an approximate solution. Because I might have lost some copper sulphate there. And there we are. It's just about dissolved. No, it's not. What I can see, if I hold this up to the camera, we can see we've still got some little crystals there. Yeah, life is not going well for me today. It's one of those problems. I wanted to label a bottle. I couldn't label the bottle. Why couldn't I label a bottle? Life is just like that. Some days things conspire against me, I think. So we'll just work on this for a moment. I don't really want to heat it up. It will dissolve quite nicely. He says hopefully. So just as I want something to hurry up, then of course it's not. By swirling this, we are bringing more water into contact with more of the crystals, which enables it to dissolve faster. Well, I'm hoping I've still got crystals at the bottom here. I've still got some that are not dissolving. Let's put this into my measuring cylinder. Let's see how we're doing. I've got about 180. I can still see I've got a fair bit of copper there, ready to dissolve. I'm just going to add a bit more water to it, and let's see if we can get those crystals to dissolve. I've given it a slightly less concentrated solution to dissolve in, and that should encourage this to dissolve better. It's just some of these little crystals that haven't decided to go. When I did it last lesson with thiosulfate, dissolves quite well. The copper here deciding not to cooperate just as I want it to. We're virtually there. I don't want to spend more time than I have to. Right, so let's just pour this in. Got a few tiny little crystals left. I haven't got many mils left to play around with. So try and encourage the last little bit to dissolve. I really don't want to dissolve these. I have to say I don't normally have this amount of problem trying to dissolve copper sulfate. Just trying to see if they're big crystals where they're breaking them up a little bit more. I might encourage them to dissolve. Just about there now. The last few remaining stalwarts here not dissolving. And we've managed it. Right, let's pour this in, and what I'm going to try and do is I'm going to try and make sure that I don't go over 250, which I haven't. Now this is not as accurate as a volumetric flask, but it will do a pinch. And what I'm going to do now is I'm going to put water in here and make it up to the 250 mark. And there we have it. So I've got 250 mils of water added to my copper sulfate, and I can then put that in. Now it's probably not a good idea to put that into this bottle that's got all this copper sulfate in already, so what I'm going to do is I'm going to put that into a fresh bottle, and I'll do that one later, because what I want to do is I want to show you something and talk about concentration. Now before I do that, the first thing I'm going to do is, I might have got some copper on my hands, so I'm just going to wash them with some soap and water. What I don't want to do is get this in me, because copper is quite toxic and we don't want, well, at least I don't want me to die that quick. Treated with respect, most chemicals aren't that dangerous. There are a few. Right, so let's have a look at some other chemicals. And the first of these chemicals I want to have a look at, doing a quick bit of tidying. A couple of bottles of squash. Now, this is ordinary squash, and this one is double strength. What's the difference between these? Well, if this is not that concentrated, it's ordinary concentrate, then this stuff is twice as concentrated. It's got twice as much stuff in there. Now let's have a look at that, and we're going to have a look at my 3 solutions of copper sulfate. Now my 3 solutions here of copper sulfate, I've got one which is called a saturated solution of copper sulfate. It's a solution where I cannot get any more copper sulfate to dissolve in there. I've got then this one, which is a 1 molar solution of copper sulfate. And I've got next to it this one, which contains a 0.1 molar concentration of copper sulfate. We can see there's a fair difference between them. This one is really dark blue, and that gives you an idea that there's more stuff dissolved in here. This one is less blue, so it's probably got less stuff dissolved in it, and this one is really quite light blue, because it's showing that we've got very little copper sulfate dissolved in this one. If this 250 had 63 in there, then this one, being a 10th, will only have 6.3 grams of copper dissolved in the water. Considerably smaller amount. So a way we can tell these, the concentration, is by talking about, well, the colour. We've got this dark colour. The dark colour for more molecules of copper sulfate in there. We've got this medium colour. It's got a fair number. And we've got this lighter colour. But let's have a look at something else. I've got my 2 molar hydrochloric acid. Now this is clear, and I've got next to it my 1 molar solution of hydrochloric acid. Students do ask me why I've got the different lids. Well, it is so I can tell the different concentrations really at a glance. This is my bench solution of 2 molar hydrochloric acid, my standard solution, and I've got here one that I use for some other things. I've got also next to it another solution. This is 0.1 molar. What does it mean? So this will have, because it's hydrochloric acid, Cl is just 35.5, hydrogen is 1, so that's 36.5 grams of hydrogen chloride dissolved to make up 1 litre. This will have twice that amount, and this one will have 1/10 of the amount. But we can't tell by colour. I have to tell here by labels. And talking of labels, my label came off of this one. This is my concentrated hydrochloric acid. This is about 36 molar. And typically the label fell off. You'll see that we've got a glass stopper on here. It's about the most effective way of storing the concentrated hydrochloric acid. My red ones, my standard solutions, warns me that they're dangerous, and the other ones, which tend to be a little bit safer. And if it's this one with the amount of dust on it, shows you that I haven't used this one for a little while. So we've got our solutions of hydrochloric acid. How do we tell them apart? I have to use labels, and the labels say 2 molar, it's got twice the amount in that a normal 1 molar solution will have, and a 0.1 molar solution. So I can look at these and I can immediately say what the strength of my solution is. Now, it happens that when we get some of these solutions, we get some that come like this. And this says this is sodium hydroxide solution, but unfortunately this one is an unknown concentration. And I know it's fairly unknown, because my son asked me how concentrated is it, and I poured a little bit of concentrated sodium hydroxide in, and then I put some water in, and I said I haven't got the foggiest idea. But maybe in this lesson we can find out. So I've got my sodium hydroxide solution, I've got my known hydrochloric acid solution, and what I'm going to do is we're going to use a titration to find out. Now, to do a titration, we're going to need an indicator. Right? Now, the indicators come in a whole variety of different types, and the types that you probably are familiar with are ones such as universal indicator. Universal indicator consists of a whole series of different indicators put together. And to make up this universal indicator, we need to take a whole series of different indicators. But universal indicator is actually made up from, as I said, several different ones. And one of those is one called phenylphthalein. Now, phenylphthalein is an odd liquid in that when it is acid, it's clear, and when, here we are, some phenylphthalein, lovely spelling, and when it's in alkali, it's pink. Now, sometimes when I'm doing this experiment, I do cheat and I use different indicators. Today I'm going to use phenylphthalein, but other times I might cheat and use perhaps one that goes from clear to blue. Another one that you might be familiar with is litmus. Litmus indicator is this sort of colour, pinkish when it's in acid and more purple when it's in this alkali solution. If I start mixing these indicators together, then we get a solution called universal indicator. But that's not what we're going to do today. We're just going to use today one indicator, and this indicator is going to change dramatically when we go from acid to alkali. And what we're going to do is we're going to take a very simple experiment. We're going to take some hydrochloric acid and we're going to add that to some sodium hydroxide. Now this we have is an unknown concentration. When these react, then we form NaCl, salt, plus water. The equation's balanced. So I know that 1 molecule of HCl will react with 1 molecule of sodium hydroxide, which will in fact give me 1 molecule of sodium chloride and 1 molecule of water. In the same way, I know that 1 mole, in other words 6.02 times 10 to the 23 molecules of HCl will react with 1 mole, which is the same number of atoms, same number of molecules, 6.02 times 10 to the 23 molecules of sodium hydroxide. So if I know how many moles of my HCl I've got, then I can react that with my sodium hydroxide. Now, to do some of this, we're going to use 2 instruments. We're going to use a burette and we're going to use a pipette. So let me set up the burette and then we'll set up the pipette to see what we want to do. So let's have a look at the burette. Right, Paul, the things to open up that there, and they're in the tubes up there. Right, Paul's just giving me some more basics. Right, let's start and have a look at some burettes. And I happen to have 2 burettes here to have a look at. Now, the 2 burettes I've got are this type, which is called a rotoflow one, and I've got perhaps what's regarded as a more standard burette. This has got a simple tap that we can turn, and it's connected to basically a measuring cylinder. And you'll notice at the bottom the measuring cylinder is at 50, and if we go right to the top down here, it's 0 here. So they're sort of measuring upside down. And it doesn't matter which type of burette we use. For many schools they use this type of burette, although a rotoflow one can be a more accurate way of using one. They just vary. I'm going to use not the rotoflow, I'm going to use this one, and I've got a setup here with my burette, and we've got a burette stand here to hold it. So I'm going to set it up and I'm going to close the tap. we're ready to go. Near enough. First thing I want to do is I'm going to play with acid. So I'm going to put my safety glasses on. There we go. Right, why am I going to need that? Well, let's have a look and see what I want to do. What I want to do is I'm going to put some of this sodium hydroxide in here. So if I reach all the way up, this looks pretty dangerous to me. I'm not going to manage to fill that. I could make my life easier by putting a funnel up the top here. That's going to probably stop me spraying it as much in my face. And now I can reach above my head. I'm not going to do that, it's too dangerous. So we need to try and find a safer way of doing this. And many schools will say, well, go and put these on the stool. I don't have a stool, I'm going to cheat. I'm just going to put mine on the floor. So let's put this on the floor. And this is where you notice that I look very good from the top up and not so good from the bottom. Right. So I'm going to put my funnel in, and I've got my unknown solution, my unknown concentration of sodium hydroxide, and making sure the tap is closed, I'm going to pour some sodium hydroxide in here. There we go. And now I can pick this up and I can remove my funnel. This got sodium hydroxide in. I'm going to put it somewhere safe. I've got an amount here. I'm not worried the amount, and I'm going to do something that I would normally not recommend doing, is I'm going to pour this back into the bottle. Now I'm going to pour this back into the bottle because at the moment I don't care about the concentration of this stuff, and what I'm going to do is I'm going to let some of this sodium hydroxide out, and what we're going to do is we're going to look very carefully at the top here. And Paul's going to try and focus in on that for you. And I'm going to try and turn it so you can see it a bit better. And I'm going to let the liquid out until the bottom of the meniscus is on the 12. My burette's ready to go. My other liquid that I want to play around with is my known hydrochloric acid, and we know that's 2 molar. And what I want to do with that is I want to put that into the container we're going to work with. So let's get my reaction vessel out. And what I've got here is a conical flask. And I'm going to put an amount of my hydrochloric acid in there. Now, how much do we want to put in? Well, we can choose, but I've decided that I'm going to go for just 10 mils. And to put 10 mils in, then I need to find a suitable way of getting 10 mils in. And to do that, what I'm going to use is a pipette. And this pipette holds exactly 10 mils. in the old days people used to suck up these liquids. Hydrochloric acid, I don't really fancy doing that. So what we have now are different ways of pulling them up. Some people have bulbs. I prefer these things. They're a little bit more accurate. And what I do is I can attach my pipette to this filler. So I've got my filler. And I put this into the liquid and I start sucking up. And when I've done that, I've got a button I can press to let the liquid out. Let's do that in practice. So I've got where I want to put it. I've got my acid. I'm just going to loosen the lid. I'm going to wind my pipette back down to start with, and I'm going to get at a suitable level so that I can see what I'm doing. And what I'm going to do is I'm going to bring up the acid into the pipette. I've got the required amount. I'm now going to transfer that to my conical flask, and I press the button and the liquid's going to come out. Or I can squeeze it out, which is what I'm going to do. And there, I've put in here exactly 10 centimetre cubed of acid. Before we start the experiment, we want to put in some indicator, and I'm going to put in just 2 drops of phenolphthalein. And we're going to swirl it to make sure it's mixed. We're now ready to perform our titration. I've got 2 molar HCl and I've put in there 10 centimetre cubed. I'm going to react that with so much of this. So we're set at 12, so at the moment I'm going to record I'm starting at 12 centimetre cubed, and let's put some phenolphthalein in here. Here we go. 2 ways of handling a burette. One is to come this side, which you then won't be able to see, but that's going to tend to pull this out. So I'm going to work this side where I can pull it towards me, and I'm going to now just let in a little bit of my sodium hydroxide. Now what you might see here is it's going a little bit pink. And as it goes pink, it's disappearing. I'm going to give that a good swirl. And you'll see that the colour then disappears. Here is my pink. We'll see that we swirl it, it disappears. What we're looking for is getting to a point where when I swirl it, nothing happens, it stays pink. And as you see, we've reached the point where it's actually all reacted and all gone. Now, that gave me an idea about where it went. So I started off at 12 and now I'm at 30.5. So I went from 12 to 30.5. So I know if I do a calculation and take these away, that it's about 18 centimetre cubed of this stuff that I'm going to need to react with this. So that was just an approximation, just to give me an idea of where it's going to go. So now we can do the same titration all over again, and we're going to see if it works. So let's set everything back up. I hope you can remember what we did. We took a conical flask, we take our acid, and we're going to put exactly 10 centimetre cube of this acid into the conical flask. So let's just do that. I'm sorry if my arm is in the way. I've got the right amount, hold it, and then I can put this into the flask. It's not coming out terribly well. I am just going to squirt it out. There we go. Put the lid on. Let's move it out of the way. And my phenolphthalein, I'm going to want to put in 2 drops. Can you hand me some paper towel? Got a little bit of a drop of alkali down there, so I'm just going to wipe this. Now, one of the things I do have with this, it's a white retort stand, white base, and this is very useful if you're trying to look at a colour change. Now I've got 30, it's just about going to work. What I'm going to do is I'm going to make one extra change to this, and what I'm going to do is I'm going to restock my burette. So I'm going to put it on the floor. I'm going to get my funnel. And I'm just going to put in a little bit more of my unknown concentration of sodium hydroxide. And basically I'm just restocking this so that it's not going to run out. And get rid of the conical flask. And I'm going to set this to a nice number. I'm just going to use a little bit of the old stuff, I'm not really worried. I'm just going to take this to 8. We're ready to do our experiment. I've got 8, I want to put in about 18. So let's say 15 is about what I want to put in now. So if we simply add 15 onto it, it's about 23. So we can probably put in that sort of amount to start with. So let's put in a little bit of this and see how we go. I do love it when my experiments don't work properly. What I've got at the moment is it's a little bit blocked, I think. Yep, it's blocked. Problem with doing live experiments, isn't it? Sort of little things can go wrong. And at the moment this is blocked. I've put in only from 8 to 15, so 7 centimetre cubed, and we appear to have a slight blockage in here. I don't know why. Not much I can do apart from give this a good clean and start again. I can see what the problem is. Could you get me a needle or a pin? What I've got is I've got a small little bit of blockage down the bottom here. So what I'm going to try and do is see if I can just put a little pin in there and see if I can unblock it. It's where I've got an unknown concentration of sodium hydroxide, and that's causing a few little problems. Well, we'll see if that's going to solve my problem. And I can see that it had no such effect whatsoever. No, we're going to have to do this the hard way. Right, I've got sodium hydroxide on my hand. I'm just going to wash them. I can tell I've got sodium hydroxide on my hand because my hand feels slippery, soapy, because the sodium hydroxide tends to react with the salt, the oils in your hand, and reacts with those quite nastily. And so if we put quickly wash it, rinse it and put soap and water on it, then the problem goes away. Right, so my titration, it's failed. What am I going to do about it? Well, all I can do now is to clean the equipment up and have another go. You saw one titration, and that's now not going to work doing this one. This is now all blocked. So what I've got to do is basically clean this thing out, and that's the only option I've got. So next time we'll have a go at doing this titration again, and we'll try all the calculations to see what we can do with it. So I'm sorry it didn't work. That's working live and seeing what happens there. So if you enjoyed what you watched, you want to even see it working next time, then please remember to subscribe, and I will see you same time next week. Thanks for watching. Bye bye.